An urban heat island is a phenomenon which occurs after the heat accumulation within urban areas due to urban constructions and urban activities. My first task today is to show how I have identified urban heat island signatures using data from satellites. The next task is to show you why satellites are useful in countries with scarce resources to monitor environmental variables in cities, especially in Latin America. Then I will show you some impacts of heat in tropical cities like Santa Cruz. To begin, last year in 2023, media has put attention on this issue because reports indicated that at least 7 people have died because of heat stroke during the month with the highest temperatures registered in Santa Cruz. But not only people was affected, high temperatures affected also livestock production. Now, my next question is, considering that Santa Cruz relies completely on groundwater for drinking water supply, how is drinking water supply affected? That is my research about. At this time, I will show you my concerns over a city of 1.2 million people located in central western Amazon. For this purpose, I will use data accessible for the public from the Modis Terra platform. I have used land surface temperature from year 2000 to year 2023 from an area affected by an aggressive and unplanned urbanization processes affecting the Amazonia forest. Well, one of the consequences of land use change and forest loss is the alteration of the surface energy balance, which in turn alters the surface and subsurface water balance. In this case, I will try to demonstrate that drinking water supply can be affected. Please look at the figures in the upper part. I am comparing their imagery from year 2000 with imagery from 2020. The two images show the dramatic impact of unplanned urbanization in a city located in the Amazonia region. The figures below will show you the impact of such change in land use by comparing between groundwater recharge zone affected and city downtown. Temperatures in downtown is much higher than temperatures in the city outskirts. Here the difference in temperatures are between 3 degrees and 4 degrees Celsius. Sandy soils characterize the groundwater recharge zones with high infiltration rates. Then, when urbanization processes occur, soil becomes more compact and in some areas land is paved, reducing or blocking infiltration and causing an increase in surface runoff. Then, together with an increase in surface temperature, which could be translated into an increase in evaporation, sum up to more losses for groundwater recharge, hence reducing water available for drinking water supply. To express the association between all those variables, I have calculated a simple equation in representation of the soil-water balance. The results are shown in the figure in the lower part of the slide. The interpretation of the figure is simple. Above zero positive values, soil-water balance indicates that ground storage will have a gain. For the contrary, when the soil-water balance is below zero, means that water losses by evaporation are higher than precipitation inputs, which means that there is less water available for infiltration, for instance, to recharge groundwater reservoirs. However, after urbanization processes intensified in the middle 2010s, soil-water balance gets altered. Then, a comparison between before and after 2010 defines different recharge dynamics. Downtown temperatures can be from 3 to 4 degrees than land surface temperatures in the surrounding of the city. Because of that, we say that satellite imagery has identified a urban heat island signature for this city in the Bolivian Amazonian region. Given that also precipitation trends have changed, questions remain on more precise values to understand how the future trends of water supplies will be in the future. Thank you.